Hello everyone, welcome back to the continuations of our NECO 2026 past questions. So today, this is what we are having today. A piece of copper ball of mass 50 gram at 120 degrees Celsius. This topic is under its capacity. And there's one thing to understand, as all these questions that we are solving, they are common in WAEC, they are common in JAMB. It's not mainly in NECO questions. You come across this. So in both WAEC or any external exams. So most students used to run away from its energy, its cap, and it's very easy. Very, very easy. So let's interpret the questions and see how to solve it. Let's go together. A piece of copper ball of mass 50 gram of copper. So solution now. So let's do that together. Solution. The mass of copper, Cu, is 50 gram. Convert it to kilogram. In physics, is kilogram divided by 1,000. So 0 cancels 0 is 0.00. How many 0 there? So you're having 2, 0.5 kilogram. At 120 degrees Celsius, leave this theta. We don't need that theta. Anytime you're interpreting, just leave this fiele. You don't need to do anything there. It's placed in the copper calorimeter of mass 80 gram. The mass of copper calorimeter, CUC, is 80 gram. Convert down to kilogram, 0.08 kilogram. Containing 100 gram of water. The mass of water, 100 gram of divided by 1,000 is 0.1 gram, kilogram. Sorry. If the final temperature of the mixture is 30 degrees Celsius, ignoring its loss, calculate this, okay? So, and we're having C, specific capacity of water, means C of water, 4,000, that is 4,200 joule per kilogram per Kelvin. That is meaning of 4.2 times 10 per 3. When you multiply it, you have 4,200. So specific capacity of copper, C of copper, 4 times 1,000, that is 4,000 joule per kilogram per Kelvin. As you can see it on the board. So let's see whether it's 4,000 or it's 4, okay? So it's 400. So this is per 2 is 400. 400 joule per kilogram per Kelvin. So let's go straight. Enter your interpreting. You don't need to focus on the temperature. So Eka say the temperature and all what you have, they just bring them out. I'm having 120 degrees Celsius for copper. So I'm having copper. Copper is 120 degrees Celsius. 120 degrees Celsius. So at this middle, we call it final temperature. So what is final temperature? If the final temperature is 30 degrees Celsius, 30 degrees Celsius, this final, that is what we call theta 2, is 30 degrees Celsius. This is what they call final, or they call it equilibrium temperature. Then from here, from here we move to another temperature. If you have another temperature there, calculate the temperature of the water. We don't know the temperature of the water. We don't know. And at this point here, it's not only water that is there. They mentioned two things here. Of mass 120 is placed in a copper calorimeter of mass 80 gram containing 100 gram of water. Here, there is copper calorimeter here, CUC. And at the same time, there is also water there. So this theta here is sharing for copper calorimeter and water. Why this one? This one is only for the copper. So let's go to the ranges. At B by 120 minus 30, that is 90. From here to here, 30 minus theta. So that is all. Is this one that is going to guide you with what you need? So if you want to get the formula, like just go straight to the formula. Here now, our formula is Q is equals to MC change in theta. That is the formula. So the first one of copper, Cu. So focus on Cu. All of them should be Cu. So the Q of copper now, Cu, mass of copper, 0.05. The specific capacity of copper, 400. The temperature of copper, 120 minus 30, 90 times 90. Q of copper, that is 1800 joule. So let's go to the next one now. I'm done with copper. Q of copper calorimeter, Q of CUC, meaning MC change the theta, MC change, that is the formula. So M of CUC, C of CUC, change theta of CUC. So let's go there now. What is M of CUC? 0.08. What is C of CUC? C of copper, 400. The theta of CUC, this CUC, the theta is 30 minus theta times 30 minus theta. So multiply this times this 32, open bracket 30 minus theta. So 32 times 30, that is 96, 960, minus 32 times this, that is 32 theta. So I'm done there. The other one to do is this, of water. Q of water is equal to MC change the theta, mass of water, so it's capacity of water, this one too of water. So let's go there. What is mass of water on the board? Look at it, 0.1. The C of water, 4,200. The specific capacity of water, check it. So we've done that. The change in theta now, change theta of water, this is it, 30 minus theta. So let's go. This times this, that is 420. Open bracket 30 minus theta. So 3 times 2, 6. 3 times 4, 12. 0, 0. Minus 420 theta. 420 theta. So and from our answer here, they let us know that ignoring its loss, let us know that its gain is equals to its loss. So why is your gaining? This is gaining. Why this one is losing? For 120 to 30, but this one they are gaining. This is gaining, and this one is losing. So these two, copper calorimeter and water, they are gaining. So add them together. So the copper calorimeter, what is the answer? 960 minus 32 theta plus, what do you have there? 1260 minus 420 theta is equals to its loss. What is your its loss now? 1800 joule. 0.05 times 400 times 90 is 1800 joule. So we're having 1800. So let's add this together. This plus this, we are going to have 0, or let's do that, 12600, 960. So this 0651, that is 3, 13560. 13560 minus 320 minus this, that is minus 32 theta minus 420 theta. What do you have? Minus 452 theta is equals to 1800. So let's collect like times. 13560 minus 1800 is equals to 452 theta. This is coming in and that is going out. This minus this. So let's use calculator to get that. 13560 minus 11760 is equals to 452 theta. 452 theta. Divide by 452. Divide by 452. So this cancel this. So my theta is equals to, divide by 452, 26.02 degrees Celsius. So you look at the answer. This, if here is 120, this place will be 30, and this place will be 26. So they are going down. So the temperature of water is approximately to 26 degrees Celsius. So they share the same thing. Water and copper calorimeter, they share the same temperature. And don't forget to like and follow for more.